Welcome to this video. I'm going to take you through the Edexcel GCSE Computer Science June 2015 exam. But before we start, I just wanted to show you the grade boundaries for last year. So if you don't already know, there's a set of videos on my channel that cover this course, so all the theory you need for the exam. And in the first ever video on that series, I think I called it Introduction or something like that, I showed you the overall grade boundaries for June 2015, which so far is the only active year of this course. And helpfully Edexcel have actually recently uploaded the broken down version, so both for the exam and the controlled assessment. So for the exam, out of 90 marks, that's a maximum mark for this paper. To get an A-star last year you needed 67 marks, which is quite high, to be honest. It was slightly higher than I thought. I mean, it still can drop 23 marks, but in the first year of any course it tends to be quite a low grade boundary because there's less resources to go on, there's less practice papers, usually only one or two samples. You have two samples in this case, and it tends to be lower. So I imagine, even though these are higher than I thought, I mean, you might be thinking these are quite low, but I think for you in June 2016 or June 2017, there won't be an exam for this course after that point, it'll be higher. So don't bank on these grade boundaries. I would never recommend doing that for any subject because they do fluctuate in quite a lot in some cases. So never rely on grade boundaries. But this is what we're going for this actual paper. And the June 2016 exam, which is what I'm recording this ahead of, is on the 8th of June. It's a morning exam and it's 2 hours long. So if you're watching for June 2017, this will be a different date. So disregard this. In terms of the front page, as I say, the time is 2 hours long, which is probably one of your longer GCSE exams. You can't use a calculator, that's quite clear, so don't even bring it into the exam hall, it's not worth the extra stress. It's out of 90, as we've said, and when it's got an asterisk, these are ones that your quality and communication will be assessed, and we'll come to those later, and we can start. So the very first question is showing us a block diagram of a robot. And we have to put across to identify where each of these is an input, process, output, or none. It's worth 3 marks. So quite a gentle introduction, to be quite honest. First of all, we have to sort of label an actuator. The block diagram doesn't really matter. It's not really pertinent to the question. If you just looked at the table, you could work it out, but this is there to help you, I suppose. So an actuator is like a motor. Really, the job of an actuator is to convert electrical signals into kinetic energy, so motion. So really, the output, or the point of an actuator, is to output some movement. So how we went to do this, we went to cross the box. We can't tick it or anything, so we have to do a little cross, and it's an output device. Anything to do with a sensor, so in this case an infrared sensor, is always an input. It's taking in some information, in this case heat, so infrared, so this is an input device. A wheel is neither an input device nor a processing device nor an output device, so it's none. Calculate distance isn't an input, this is just a process, so this could be speed times time to work out the distance, and it's neither going to be an input device. It's going to have an input, 2 inputs potentially if we're doing speed equals distance over time, and it's going to have an output, but the actual process of calculating the distance is a process. The programming language isn't an input, process, or output. It's not related at all, so it's again none. And a movement sensor, again, like I say, anything to do with sensor is an input device automatically. For part B, we're told the robot stores information as binary sequences. State 2 types of information that binary sequences can represent in the fetch, decode, execute cycle for 2 marks. So we get a mark per point. This is it's not exactly explicit, but it's testing you on the stored program concept. And this is the idea that both data and instructions are stored in the main memory. So, in the fetch stage, we're getting the instructions from memory, so let's just write instructions down, and then usually it's put into the execute category when extra data that's maybe needed in the calculation is then also fetched, but not in the fetch stage. So we also have data. I've got the examiner report up on my second screen. It's always pretty useful, and I recommend you look at the examiner reports for all your subjects. Whenever you do a past paper, see if there's an examiner report available. They tell you things that people got wrong and maybe give some advice too. So they said most people got instructions, but not everyone got data, and people actually gave specific examples, so just bear that in mind, although hopefully most people would have got that. For part C, we're transitioning to talk about assembly code, and we're given an excerpt of an assembly code table and some extra mnemonics for sort of conditions. We're also now shown a section of assembly code from the robot's program, and as it says, the line numbers here aren't part of a code. And for part I, we're told to state the line number that contains an instruction to perform a test. So okay, so let's just talk about what these opcodes are. So we have move twice, we have subtraction, we have move, we have add, move, compare, branch not equal, and move. We can just look these up if we weren't sure. It'll be a lot nicer in your exam because you don't have to scroll up and down. So the only one here that does anything vaguely about performing a test. So a test in programming, this is programming, but in a high level programming would be something like is the variable, let's call it num, greater than 10, and so also something like, or if we do this actual case, so the answer is this one, by the way, let's write it in, so it's 121 is the line number, and this is comparing the value in register 5 to 0 in this case, because the hashtag is something called immediate addressing. It's signalling that we're going to be we're literally comparing 0 as opposed to an address or another register. So essentially here we're going is register 5, if this is a variable, equal to 0. So in some programming languages, to say equal to, we do two equal signs, like in Python for example. So this is the test, and this is what compare does. On a similar theme, we now have to state the line number that contains an instruction to change the flow of execution. So what is going to change the flow? So at the moment we're essentially just executing through it very nicely. We're then comparing this, and then this means branch not equal. So if this turns out, if they're not equal, it's going to branch back to label 2. So label 2 is up here, so it's going to go back to here. And this is what's changing the flow of execution. The rest of it is all a nice sequence block, but this is actually a selection block. I just gave the game away of part 3 because I said selection. So it says test that can change flow is the same as a high level programming construct, and this is selection. The other two you need to know are sequence, which is just where it executes line by line, as I was saying, at least when it's high level, and we then have iteration, or it's called something else it's called repetition in Edexcel. So this is just when it loops around. It could be a for loop, it could be a while loop. But we now have to do some binary, and we're told the robot is 12 meters from an obstacle. 12 is positive denary. Fill in the table to show the number 12 in 8-bit binary, so it's a byte, using a sign and magnitude representation. So first of all, with sign and magnitude, the most significant bit, so this is the most significant bit, this is the least significant bit. In sign and magnitude, the most significant bit, the one furthest to the left, is always representing the sign. So like in denary minus 10, we have just 10, the magnitude of 10, and then we have this sign telling us whether it's positive or negative. And it's the same using sign and magnitude. There are reasons why it's not really used widespread, but we won't go into that right now. So when it's 0, this is positive. When it's 1, this is negative. That's not gone well. Anyway, so it's positive, so we can straight away just put 0 here. And so 12 isn't very difficult to convert to, because it breaks down into 4 and 8, which are two binary columns, so it doesn't it's not very difficult, but I'm going to show you how you do it with table anyway, because that's what I showed in the video. So it's binary, so the columns double each time because it's base 2, in the same way that in denary decimal it's 1, 10, 100, 1000 and so on. So we don't fill in a value for the most significant bit when we're doing sign and magnitude. So to convert from 12 to binary, we say how many times does 64 go into 12? It goes in 0 times. Same with 32, same with 16. 8 goes in once. Remainder 4. We could just put this here, and then we have 4 goes into 4 one time, and we can put zeros here. So it's not the hardest one to do. It's only worth 1 mark, but this is the tricky bit, I suppose. Remembering that you have to make the most significant bit a 0 to make it be positive. I'm not going to explain it fully because you can obviously watch my video, but we now have a different number, so we have negative 14, and now we're changing the representation we're using. So we're now using 2's complement as opposed to sign and magnitude. So when I think 2's complement, I immediately think, okay, I'm going to do 1's complement and then add 1. So 1's complement is when you basically flip the bit, so you reverse it. A 0 becomes a 1 and 1 becomes a 0. I showed you 3 methods in my video called binary to do this. There's one that uses a negative most significant bit, which I personally don't like. I've never used it myself because I have no need to. This is only worth 1 mark, so your method doesn't matter. You could, so one way of doing this is, first of all, for any method, we need to work out what positive 14 is. And without doing the table method again, which of course you could do, this is 12, this bit here in green is 12, and to make 14 we just add another 2, so it's going to be this. Again, the far left digit is also kind of representing the sign, so this would be 0 anyway, even if you were just doing plus 14. But then we need to, so this isn't our final answer by the way, this is just a placeholder. We then need to, if we're doing my method with 1's complement plus 1, we now have to flip the bits, so this would be 0, 0, 0, 1, 1, 1, 1, plus 1. I've done this over a barcode, which isn't too helpful, but a bit of binary addition. This 1 plus 1 is 0, carry a 1, and then we just fill it in from there. So I've moved it so it's not over the barcode, which is a bad idea. This is our final answer, 11110010. The far left bit, the most significant bit, is telling us for this negative. Just to show you another method, and I'm just going to actually write this one down. So this one is a method that I was introduced to last, so I haven't really got into using it. But first of all, we basically, so this is, for 14, this one's a 1, so if you imagine this number, but this is a 1 instead of a 0. We first of all copy from right to left, and until we write down a 1, so we write down at least a 1, and then we change every other bit. So this is now 1, 1, 1, 1, because we're doing the opposite to what is above, and this is the same as our answer. So this maybe saves a bit of time, but it's the same answer. It's only worth 1 mark, so you get your mark for the answer. You might have done a tiny bit of binary addition already if you did the 1's complement plus 1 method, but we now have to add two 8-bit binary integers and write the result in the last row of this table for, again, a single mark. So you're doing quite a lot of work for just 3 marks here. So within binary addition, you could just write in this if you really wanted to. In fact, let's not do that because that's not a very straight line. So first of all, 0 plus 1 is just 1 in maths in general, but when we have 1 plus 1, we have to have an overflow. So we have to, so we write a 0 down. It's not really carrying a 1, but we'll write another 1 down. 1 plus 1 again is we write 0, put another 1 up here, again, another, again. I can get a sense of what's coming here. So we end up with just 1 plus 0 plus 0, so we write a 1 here. It's irrelevant to the actual question, but if you wanted to check, you could just convert these to denaries. So this is 86 plus 43, and the answer, the bottom one here, is 129, so it works out, which is good. I was actually wrong when we were doing this. I thought I'd end up with an overflow error, but actually it says in another calculation, so not this one we've just done, don't get confused. It generates an overflow error. State was meant by the term overflow error. So this is when you add together two numbers which result in an answer that's longer than the space you have allocated. So if we're dealing with so it says 8 bits, so the maximum you can get with 8 bits is 2 to the power 8, which is 256, or when we're dealing with numbers, this is 0 to 255. So if you end up with a number that's greater than 255, you're going to overflow into the next column, which is 256. So the result of the addition cannot fit into the size of the 8 bits you have allocated. You can't just, in binary and in a computer, you can't just go with your allocation. You have to stick to your allocation. If you say you're going to use 8 bits, you can't then use 9 bits. So we effectively miss out. This wouldn't get stored. I've said the result is too large to be stored in the allocated space, in this case 8 bits, so it would be at least 9 bits needed, and so the result is greater than 255. There are various ways you could get this mark. And then it says state what happens if the overflow error is ignored and the result is used in other calculations. Well, let's take not so much an example, but if this was 2's complement, we end up, so say, okay, so this is not relevant, this addition is perfectly valid, but say this was as far as we could go, and this spills into the 8th column. So if this was representing so say this was sign and magnitude, this is saying for both are positive, as we are 86 and 43, but then this says this is now a minus 1, if this is what we're doing, which we're not. So the sign could be changed, which could be a major implication. So essentially, the result is then going to be used in further calculations, and it would give you a wrong number. So I said it would introduce further errors, perhaps because the sign has changed. Hopefully that makes sense of what I've tried to add to this little addition. We're showing a block diagram from the first page again here, and we have to construct a truth table for a not operator that is used to reverse the state of a single light. Use any familiar notation. A truth table shows all the possible combinations for a Boolean operator, so not and or in your case. And with a not, it's the simplest one. So not only takes a input and gives a output, which is why I've got two columns here. So we can write input here, output. We could write any letter here. You could just write O and A or something, or X. Doesn't really matter. So for example, not 0 would be 1 and not 1 would be 0. So I say, for example, these are actually all the combinations. We have 0 becomes 1 and 1 becomes 0, and that's it. We could do an extra line here. We're told to refer to the robot diagram, so I was wrong earlier. We actually have got to look at the robot diagram. We have to assume R is a red light, blue is a blue light, and S is the speaker switch. But we don't need that for part I, because we're told to complete the table to show the Boolean expression Q, which is now our output variable, which is not R and B. So we have to evaluate this first. In the same way as in maths, we have to evaluate anything in a bracket first. We do this with Boolean expressions too. So these are our two inputs here. We then have this intermediate stage to help us, and then we have to have our output too. So when both are 0, we have not R, which is now going to be 1, and B, which is 0. And for and to evaluate to 1, both sides have to be 1. So if 1 is 0 and 1 is 1, it's going to be 0. If both are 0, it's going to be 0. It has to be both 1 for and to be 1 equals 1. So this is going to be 0. In fact, I'll skip the step, so not R equals 1. I'll do this as I meant to now. So not R is in this case 1, and we have 1 and 1, which is 1. Not R is now 0, so we have 0 and 0, which is 0. We now have 0 and 1, which is still 0. For part I, we still don't really have to refer to the robot as it says, because we're told that R is the red light, blue is a blue light, and S is the speaker switch, and we have to construct a Boolean expression, so we have to write one of these ourselves to determine if either light is on. So either straight away implies we're going to use an OR operator. Then at the same time, this immediately implies we're going to use an AND operator as the speaker switch is on. So the speaker switch is kind of independent here. Okay, so the answer is Q, which is our output, equals so we have the two switches are red and blue, and we need either to be on. So if one's off, as long as the other one's on, it's fine. So R or B, red or blue, at the same time as the speaker switch is on. So this is going to be then and S. So let's test this out. So if S is on, we can put a 1 here, and then say if red is turned off, so this is 0 and this is a 1. Well, OR is, I think of it as being less fussy than AND. So the only way OR is going to ever equal 0 is if both sides are 0, so 0 or 0. So if 0 or 1, this is just going to evaluate to 1. Then you have 1 on both sides, so the output would be 1, and this is kind of testing this condition. So this is how it breaks, and hopefully you can see this. I don't know how well I've explained it, but I think it's very logical. You got to basically interpret what they're saying if you get a question like this, and it's going to be either is going to automatically mean or, and at the same time is going to be and. So you've only got 3 options to play with really, and, or, and not. So I'm just editing, and I thought I should show you something I read in the examiner report a bit later, which I should have pointed out really, I just didn't think about it. So you could just write R or B and S, so essentially write it without the brackets. Problem is, we have this order of precedence in logic, and that goes not and or. So you evaluate anything to do with not first, then and, then or. So you're kind of evaluating this bit first, as it says. Essentially, you're using the bracket. You're not writing a bracket, but you're doing it as if there's a bracket for B and S, because and goes before or. It's a bit like in maths with BIDMAS or BODMAS, whatever you're used to calling it. So you kind of need a bracket to show that this is the thing you're doing first. For question 2, we're introduced to a biologist that uses application software to help him in his work. For example, he uses spreadsheet software to model the behaviour of bee colonies, and we have to identify two other not spreadsheet software. Notice, by the way, it's not using for brand names. So you might be using Microsoft Excel even, but we're not going to call it that in the exam. Never use brand names in an exam. So don't say iPhone when you mean just a mobile device or a touchscreen device or something. Just don't use brand names, full stop. And we have to identify 2 other types of application software, so this is relevant, and give an example of how the biologist could use them in his work. So we have to apply this. We're not going to get a mark for just saying generic purpose of spreadsheet software. We're going to have to give an application relevant to this guy who's obviously involved with bee colonies. So not something many people really know about, but you don't have to know too much about it to answer this question. Fortunately, I'm not the one sitting in this exam, so I can use the mark scheme to show you the answer here. There's lots of possible pieces of application software. So application software is really just for programs, for software that performs tasks, specific tasks, if I can say it, for the benefit of the user. Because where something like is contrasted with system software, which are things like utilities. Even the operating system would be classed as system software, which are tasks needed to operate the hardware really, as opposed to perform a benefit like be able to search for things or do presentations and so on. So it does give some examples here. So for example, using a web browser to look up the address of a colleague, you could just say for looking up details about the work or something, but make sure you be specific to what a biologist might use. Same presentation, maybe doing a report, video editing, so yeah, a video of lectures or research, so on. So I'm not going to fill this in because don't really need to. So we can move on to look at part B, which says that software may be classified as open source or proprietary. Say 4 features of open source software licensing. So this is something actually not covered in the software video. This is covered in the last video in my series, which is called something like Emerging Issues, and it kind of refers to intellectual property. That's kind of the topic it falls under. So proprietary software is software that's licensed under strict conditions. License pretty much means you have permission to use it legally, so you've usually bought it, but that's not always the case. So this means the strict conditions tend to mean that you can't modify it, so that could be an option, and you can't do that. You also can't distribute it usually, so we can cross those out. And basically open source software is the opposite. So the reason I'm talking about proprietary is nothing to do with the question, but you might get this actual question just the other way around in your actual exam. So open source software is where the source code is publicly available. In fact, that's going to be one of our points. You need to think of 4 points here, so I might as well write it in. This, I should have said, but this means there's no source code available with proprietary software. Usually open source software is available free, because if a source code is made available, basically anyone can copy it, which is tricky. It might still be under copyright, but people can copy it and maybe rip off your software, so you might as well make it available free. Whereas proprietary software, again, doesn't have to be paid for, but usually would be, because usually it's proprietary because they want to keep their source code under wraps, essentially. Microsoft don't want anyone to see the code they use to write Microsoft Word, because it could just be copied. So usually, and this is quite an important point, it's usually source code is usually open source software is free. So I've underlined usually again. If you just wrote open source software is free, you wouldn't get a mark for that, because it's not necessarily, it's not always free. It doesn't have to be. It's not by definition that it's free, it just tends to be. We can write down one of these points from up here, because the opposite is true. So whereas you can't usually modify under proprietary software, you can modify the code for open source software. Sometimes it's encouraged, sometimes it's used for educational purposes. And again, whereas proprietary software can't be distributed, we can, let's say, redistribute open source software. And so this means you can't, well, this doesn't necessarily mean it, but you can't then sell on someone else's software they've made open source, because I think part of the license granted to you when you download open source software or buy it when it's not free means you can't then sell it on for more, or possibly even sell it at all, because you can't stop anyone else from benefiting from it if they want it, kind of thing. Because the point is, the code is made available. You can't limit someone else from having the same use of it as you are, unless you've paid for it, but then that's not usually the case. For part C, we have to complete this diagram by adding 6 arrows to indicate the input and output relationships between these devices. So these devices are a visual display unit. So this is quite an old term, I think. Really the category of this is things like screens, projectors. I'm not sure what else is in that category, but just an output device. So we can straight away just draw an arrow from a CPU, which is the processing unit. It's what's processing the data. Processing the data that's going to be shown on this screen, if it is a screen. So it's just a one-way arrow this way. There's no data coming back from a screen unless it's a touch screen, but that isn't specified. We have to draw 6 arrows, by the way, so that's how we know we're right or definitely wrong if we end up with 7 or something. So the CPU, with secondary storage, data is going to be used by the CPU that's come from secondary storage. So data is going to come from from secondary storage to the CPU, and also data is going to get stored on this secondary storage. So it's both ways with that one. The mouse is going to be just an input device. There's no other way the data is going to go the other way. The mouse isn't doing any processing or anything or storing any data. The main memory is also going to be both ways. So data is coming out from a CPU after something like some processing is being done by the CPU, and then obviously before that data has to go in as well. So this is 6 and this is our 3 marks. Now we're told the microprocessor inside a computing device. A microprocessor is just a CPU on a single chip. It's made up of several individual components. These components work together to implement the fetch, decode, execute cycle in the device. We have to identify one component and its function in this cycle for 2 marks, so a mark each. And I wanted to bring in this image. I'm pretty sure I showed this in the video I did on the CPU, but I think it's quite a nice picture to that contains all the components. So we could talk about the ALU, the arithmetic logic unit, which performs calculations during the execute stage, calculations in execution. That's poor handwriting, apologies. We then have the control unit, which is what decodes the instruction and in general coordinates the whole cycle. We then have the registers, which are very small, quick stores of data. They hold, so let's just say store of data. In fact, we can say store of data, instructions, and also memory addresses, like the program counter. We then have 2 buses. We need to know you can't just write bus for this for some reason. Well, it's understandable, I suppose, because there are 2 you need to know for your course. There's more than 2 actually in the computer. In connecting the memory to the CPU. But so we have the let's say this is the not control. Sorry, that's one of the extra buses you don't need to know about. The address bus and also the data bus. So the data bus, whenever an instruction needs any extra data, perhaps when extra data is needed, it tends to be put in the execution section of the fetch, decode, execute cycle, and so any extra data will be loaded onto the data bus. This bus can go both ways. Data can go both ways, whereas the address bus can only go towards memory, because this holds the addresses of instructions, or actually can be addresses of addresses of instructions, but also addresses of things for other devices, like maybe secondary storage. This is about the limit of the list of things we can talk about for this on your course. We are talking about only the microprocessor here. It does say it's made up of several individual components about the microprocessor. This is why we're not talking about things like the memory, because that's not part of the microprocessor. But any of these would get you, and the description would get you the 2 marks. Right, moving on to part E, it says explain how the operating system manages processors on a computer with a single microprocessor for 3 marks. And the single microprocessor here is the most important bit of this. Well, and manages processors, but the fact that it's a single microprocessor means we have only one CPU. So a multi-core system where you have multiple microprocessors, in essence, it's a very different process. So you can run things in parallel when you have multiple cores. So say this is a 4-core thing, so each one of these is a core. We can run up to 4 processors at once, so times 4 processors. In reality, it's not quite this simple. So it's not like the clock speed multiplied by the core equals your total speed. It might be the total possible speed, but not everything's optimized for 4-core processing. It has to split the instructions up. But we're just dealing with 1 core here, so it has to. The idea of this question is to test you on your understanding that a computer's having to run loads of processes at one time in essence, but it can't actually execute them at one time. It has to make it appear like it runs at the same time. That's what the operating system does. So there are 6 or 7 of these aspects of the operating system you need to know, which I covered in my video. I think things like resource allocation, memory management, network management, user management, and file management as well. And there's also, I think, a point about input output and how the operating system deals with that. So you've got to bear in mind you could get questions on any of these. Process management is probably the most. It's probably one of those most to talk about, which is good because we've got to basically be looking for 3 points here, and mark a point. First of all, I'm going to say when you have only one microprocessor, you can only execute one instruction, one program, one process at the same time. I'm going to stick to calling it process because that's what it says, but they're almost synonymous. So let's say a single microprocessor means you can only execute one process at the same time. However, this isn't relevant to the operating system, this is relevant to the processor, so we've got to be careful not to go off track. Really what I'm trying to say here is, however, the I'm just going to OS, the operating system, makes it appear like more than one process is being executed, is running at the same time. So if the operating system is constantly switching between processes, to make things more efficient, and also because some processes are given higher priority than others, and so a higher priority process that needs to be executed sort of immediately will just be switched to by the OS. Okay, I'll read it to you because it's a bit messy. So I've said a single microprocessor means you only can execute one process at the same time. However, the operating system makes it appear, and I've highlighted this because this is really important. I've just looked at the mark scheme, and this is a point on the mark scheme. The more than one is executing at the same time. The operating system can switch between processes, and it gives some processes higher priority, and so it gives them more time to process if they have a higher priority. Might as well show you the mark scheme actually. So we kind of get a mark. We don't get a mark for the first bit because that's not really relevant to the operating system and how it manages processes for process management. We get a mark for saying it makes it appear. We get a mark for saying it switches, and we get a mark for, I think we might even get 2 marks here. We obviously wouldn't go beyond 3 marks, so that's kind of our limit. So I might as well show you the mark scheme actually. There's a lot of points here which aren't, I think it would be a bit inappropriate to expect of you at GCSE. There's a lot of stuff in this course that's very difficult, you know, let's not ignore that. There's a lot of stuff like floating point, fixed point, which aren't even introduced at A2 in some cases. This whole concept about switching between processes is, if you want to look up, it's called multitasking. And I looked at a A-level computer science textbook I have, and bear in mind this is sort of at A2, so year 13, there's like a paragraph on this, and nowhere near the detail the mark scheme goes into. You know, if you've been taught about queues, in fact we talked about queues very briefly in the first video, the algorithm video about breadth first search and depth first search. FIFO stands for first in, first out, it's just for where queue works. But to do with time slices, you might want to, it's pretty quite important to know that you can have more than one process loaded into memory. That's sort of to do with a fetch, decode, execute cycle. But a lot of these points, I would say, I wouldn't. If you came and you were marking this yourself and you came to this mark scheme, it'd be very easy to panic and think that you've not learned loads of stuff. But actually, I think it's a bit unnecessary to know it to this detail. You can see all the points we said. I've got a point here, and it does just talk about this difference between saying 2 programs are running and they appear to be running. And so it says it's incorrect in the context of a question about a single microprocessor, because you know they're only going to be running at the same time if it's a multi-core system, and even so, not necessarily. So bear that in mind. The final part in this question 2, is another application question, and we have to give 2 examples of how software could be used in this situation to model for the real world. So the situation we're talking about is the fact that the biologist collects data on a single bee colony each day. So this includes things like the amount of available food, the number of bees, the amount of honey produced, the hours of sunshine, the hours of rain, and yeah, as I said, so you can use a software model. And really, a software model is just a program designed to simulate, to replicate certain aspects of the real world. So as you can see, I've just taken from Mark's game another question where it's two points, so a mark each. Not really much point me giving my own answers for this, because it doesn't really matter what you write in this really. It does say here, in fact I can highlight it when I bring it in here, so we can say you do need explicit connection to the context. You can't just say why a software model in general would be useful. So reasons it gives, things like implementing formulas which represent relationships between the data variables. Maybe a bit of a tough one. I don't know how many people would come up with that. You can model for economies, probably the most obvious one, but you need to write something like use a programming language or a customized application maybe. Graphical user interface components to adjust to things like plotting graphs maybe. Yeah, just say presenting output using graphs. Variables can be changed. So they're all very similar, to be honest. I don't know how many people would come up with any of these points, but hopefully you can see the kind of things you need to talk about. Make sure you are explicit in relating it to the context. Don't just say a general, even if you're dropping in colony, it shows you're thinking about the situation rather than thinking about just why software models are used in general. Question 3 begins by telling us John has decided to set up a website to promote the local youth football club, and part A, we have to basically complete these statements from Mark each. So bitmap images of the club uniform are taken with a digital camera and put on the website. So something is the smallest element of the bitmap image and the smallest element that can be displayed on a screen. So this is pixels, or let's just say pixels. It stands for picture element, but pixels is the technical term, so there's not really anything else you could really write here. There's not an obvious second alternative. The something of an image is based on the number of elements used to represent a full image. The higher the number of elements for a given size, the better the quality. So this is the resolution, which is really the detail of the image holds. So the more pixels you're using, the higher the number of elements for a given size. This is the number of elements refers to pixels. Obviously they can't tell you that because it gives the game away a little bit. The next one, something indicates the number of bits used to represent the colour of a picture element. The higher the number of bits used, the greater the range of colours. This is the colour depth. You might have to do some very basic calculations to do with colour depth. So if they say the colour depth of an image is, let's do something simple like 4, how many colours could be represented with 4 bits? So basically what you do, we're dealing with binary, so the base is 2, binary is base 2, and we write to the power of 4, 2 to the power of 4 is 16, so with 4 bits, with a colour depth of 4, you can represent 16 colours, whereas obviously if you had like a lower colour depth, so let's say 2, you can only represent 4 colours. We're given a table for part B, and we have to complete it with the name of the category of secondary storage described in each row. And I might have said this earlier, but mark schemes and bits like this can be really good notes, because these are describing the 3 categories you need to know. So when it says categories, we mean it's either going to be magnetic, optical, or solid state. So when we say category, they don't mean types. So a type of magnetic storage would be like a hard disk. Optical would be like a CD. Solid state would be an SSD maybe, or flash drive or something, but that's not what it's asking. It's asking for categories, so it's asking for bits in orange. So first one, use metal platters coated in iron oxide. The platter rotates at high speed. This is magnetic. So the platter can be thought of like a disc spinning, so this is magnetic. Small pits are burned into patterns onto a flat surface, so this is automatic. Optical is associated with eyes, so when you're talking about lasers, so this is optical. In fact, the order is perfect here. No moving parts, data stored as electrical charge, so this is solid state. For C, we're now changing to look at networks. So network protocols. Protocols are just rules for sending data. Break the files into packets before transmission. 3 fields in a network packet are source, destination, and checksum. So I might have shown you. In fact, I don't want to say might. I showed you like a visualization of what a packet looks like. So a packet is split up into sort of 3 parts. So we have the header, the body, which is the data, and the trailer. The names vary a little bit, but the field is kind of like extra bits in each of them. So that's what it means by field. So we have source, destination, and checksum. So 2 additional fields. So first of all, it doesn't say the data. So I'm going to put data down. There's other words for what it means by data. So the actual data is your body. So really, this is just one field, kind of. Second one I can think of is the packet number or sequence number. So this is what position the packet is, sequence number in the sequence. So if it's a fifth packet being sent, the 6th packet, so it knows what order to assemble it at the final destination. So I haven't seen the mark scheme as I haven't for most of these questions, so I'm going to check it now. So yeah, these are 2 given: sequence number or packet number, or the data is one of a valid one, maybe the most obvious one, but others things like the timestamp, the version of a protocol, I suppose that means, with type, things like flags, size, routing information, and so there's quite a few you can write. So these are the most 2 obvious ones. The first 2 I thought of, certainly. For D, we have to state the purpose of a checksum for 1 mark, and the checksum is there to check whether any errors have been introduced during transmission. So it's in the name, but the check bit is important because it's not correcting errors, it's not there to correct errors. So the way, it's a bit more complicated in reality, but the way it's sort of taught is a checksum. So at the beginning, before a packet is sent, all the values are added up in the packet. So let's say all the binary values for this example. So all of them are added up, and say the answer is 15 for no cogent reason. So then it's sent, and say there's been an error, so something's happened, it doesn't really matter what, some of this has been lost, and so this is stored as a field in the packet. So at the end, the thing receiving this packet adds it up again, and so it gets 16. So it's wrong, so there's been an error somewhere. It'll probably be actually less, but anyway, it doesn't matter. So what happens is it basically just gets it to be resent, and the same process will happen. So it's not correcting the error, it's just finding the error. So John now needs to convert the file sizes from megabytes to gigabytes. States how John could convert 4096 megabytes to gigabytes. So first of all, we need to know that Edexcel take these prefixes to be in terms of 1024. The actual, I don't really want to go into it, but the actual, it's technically they're in terms of 1000, but that's not how Edexcel are dealing with it. So they're in terms of 1024. And megabytes, so we have, in a gigabyte, we have 1024 megabytes. So in order to go from megabytes to gigabytes, we have to divide by 1024. So we'll just write this as, we could just do it as a fraction, so 4096 over 1024. The answer is going to be 4 gigabytes. We don't actually have to write the answer to get our mark here. This bit does not matter so much, because it says state how we could convert rather than actually convert. You get your mark for just basically saying you need to divide 4096 by 1024 even to get the answer. Just to explain this a little bit more, for most people I'm sure this is relatively straightforward, but if it's not, that's fine. So if we had 100 meters, let's say we have 1000 meters in 1 kilometer. So if we wanted to convert from meters to kilometers, we'd need to divide by 1000 too. So 100 divided by 1000 is 0.1, so it'd be 0.1 kilometers. So hopefully you can see what's happening in both cases. For F, we're told the end user will use a browser to view the club's website. Describe one difference between the internet and the World Wide Web. Notice how I've capitalised the internet. I like to see that. So, if you understand this topic, then this should be really straightforward. But actually, it's probably harder. You probably understand the difference, but actually, it may be hard to put it into words. So really, the internet is just connected networks of networks. Whereas the World Wide Web is the actual data, the actual information, in some cases, or in lots of cases, for web pages stored on the network hardware. So again, the mark scheme is pretty good for this. As it says, interconnected networks, that's really what internet means, internet with a lowercase I. It does say hardware in bold, so I think this is really useful. A good way to think of it is the internet is the hardware, so the switches, the routers, for wires maybe, whereas the World Wide Web is the data or the information actually stored, and I did write that, but I wrote half of that essentially. What else did it say? It said things like uses protocols. Okay, where's it? Okay, so the rest of it I think is secondary to the fact that the internet is actually the hardware, and that looks like a K, the hardware, and the data is what the World Wide Web is. The World Wide Web is just information uploaded onto the hardware. So John's been hard at work and has created a sample page for a website. Here's a page displayed in a browser, this bit displayed with the code. So this is a mix of HTML and cascading style sheets, which is CSS. So you have to state the line numbers that show the CSS information. So you have to know, I think you might have to write code. You don't actually in this exam, but you might have to actually write some HTML or CSS code in your exam. But I think at the very least you should watch. There are videos on YouTube like learn CSS in 15 minutes or learn HTML in 20 minutes or whatever. Try and watch those, because you'll pick up. You just have to recognise it really. So the bit that's obvious CSS is this bit here. So in fact I can probably highlight it. So from line 5 till line 10, you could include the style tags, not really relevant, so it's this bit here. I won't be able to highlight all of it, but it's this bit. And it's very obvious the CSS. CSS is there to add style to it, and this is very obviously the CSS bit of it. So lines 5 to 10, it's not just one line, it's just say line numbers. So 5 to 10. For part 2, it shows line 18 of the code. We have to explain how it's connected to the cascading style sheet information. So this is in HTML. We've got lots of tags here. So we've got li, which which is list, I believe. It's been a while since I've done anything in HTML. Not really my thing. Also a is defining a hyperlink. I had to look that up. That's really bad. So arguably the most important one is the one I forgot. So A is defining a hyperlink. Not really relevant, though. We have to explain how it's connected to the cascading style sheet information. This is line 18, which is here. So this one, and we have our li and a here, our two tags, and they're referring to. So in the style CSS bit, we have, you can see we've got a here and we've got li here, and they're I guess defining the style. So things like it's going to float to the left and margins 1 pixel. Of when you hover over a, it's not here, but it has an orange colour. The background colour is white. Things like that. So it's connected. So we can say li. You probably don't need to write the tag bit. Li is referring back to line, what line is it? So it's introduced in line 10. Likewise, a. We could also do a. The end tag refer to line 6. I don't think you need to write both to get the mark, but really they're referring back to the information in the cascading style sheet. That's it for questions on HTML, CSS. You might get more in your exam, you might not be so lucky. Moving on to look at sort of audio conversion or analog to digital conversion. So it says says interviews with the club's coach are converted to digital format. State the aspect of the signal, which is an analog, so it's continuous data. It must be sampled and stored as binary data, so that's not continuous, it's discrete, it's either 0 or 1. And so state the aspect of the analog. So with sampling, if I draw, so sound waves aren't actually like this, but if I draw a sine wave, so roughly a sine wave, when it samples, so it goes along, and let's say we're sampling at this distance, so these are sampling intervals, basically records the height. So it goes along and records the height at each sample, and the number of samples per second is the sampling frequency. So it's recording the height of a sound wave, but we don't say height, as I'm sure you know in physics. When we talk about waves, we say amplitude. Okay, so I said what the sampling frequency was without even seeing this question. So it says state how increasing the sampling frequency, so how many samples are taken per second, affects the digital representation of the original audio. So essentially, the more samples you have per second, the more this sample is like the original audio. So if we took loads of samples, it would be very similar to the actual audio. If we took a sample every kind of couple of seconds, it's going to sound nothing like the original audio. So really, the more like the original it's going to be. So this means that the representation is more accurate. This bit is, you might get a mark for this bit alone, but this sort of guarantees you the mark, I suppose. If you just said better quality, which would be true, that is true, but you wouldn't get a mark for saying that. It's not really a technical answer. So the club has a simple black and white logo. The image is compressed using a lossless. So two types, lossy and lossless. Lossless means no data is lost, as the name suggests. Run length encoding RLE algorithm. Explain how this works for 2 marks. So a run length encoding algorithm works by replacing long repeated sequences. So we're doing it in black and white, as this example is in. We could have black pixel after black pixel after black pixel after black pixel. Then we might have a white pixel, say here, then another black pixel and so on. So we're going to have lots of, these are called runs. So when you have repeated items like this, they're called runs, and that's where the run length encoding comes from. And we basically replace this with, so we have 5 here. We basically replace this with, let's go back to black for a second. We basically replace it with one of the black pixels, a representation of this. So if it was like 0, 0, or 0, or 1, whatever it is, then we also just write, it'll be another store of how many we have. So it's 5, so we'll write 5. And this is what they're trying to get you to do. So you could use an example, you wouldn't draw it out, but you'd have to explain it. But the actual explanation of what it is in the general sense is it compresses repeated sequences, which are called runs, that might be quite important, into a single item with the number of items in the sequence. Having seen the mark scheme, this would be our first mark, and this would be kind of a combined second mark. Like I say, you could do an example. If you got asked why it would be effective on a black and white image, well, you're going to have loads of repeated values, aren't you? Loads of repeated items, pixels in this case. Whereas like if you had a picture of, the countryside, a lot of it's going to be green, but they're going to be different shades of green, so you're not going to have repeated runs in that sense. Whereas the black and white images are going to be one of 2 things. There's bound to be loads of repeats, and so I'm sure the file size could be compressed a lot by using a run length encoding algorithm. For question 4, we're told AJ's is a fast food company of 5 outlets. The outlets are connected via the internet to the head office. Data from each outlet is transmitted to the head office computers at the end of each day. The chief executive is concerned about the environmental impact of these computers. Give 3 possible environmental impacts of using these devices and suggest 1 action this company could take to reduce this impact. So this comes from the last topic in the course. It's really important you go in with some things to talk about. So it's also legal, social and ethical impacts you could be asked about. So you could get a very similar question with one of those other ones, or you could get environmental again. So I think the most obvious one with environmental is pollution, but it's not the only effect. So pollution, you probably should specify what, you can maybe even drag it out. I wouldn't recommend you drag it out, you've got to make a separate point for each one. So pollution, you can have air pollution, which is probably most obvious, so like smog. If you ever see pictures of like China, Beijing, just, ridiculous amounts of smog. Water pollution, so sort of contaminated water, and noise pollution too. Whether a noisy computer is really going to contribute to noise pollution, you can, well, I wouldn't talk about noise, to be honest. You could talk about air or water. Another, maybe less talked about, would be like resource depletion. So problem is these devices, computer devices, I don't know about the computer they're talking about here, but things like phones have very small traces of things like gold, maybe silver, maybe even platinum in some devices, because they're very, well, they're good conductors. I don't know about the best conductors, but they're used mainly because they're very unreactive, and they're using tiny amounts in these devices, and loads of devices using tiny amounts adds up to quite a lot of these resources. Obviously they're finite resources, and it's difficult to extract a tiny bit of gold from an iPhone, say, after it's been used. I know Apple have been doing this recently. Apple made a lot of money, or they got a lot of money back from just trying to get this small amount of gold out of their devices, because otherwise it's all going to go to landfill, and these tiny amounts of gold are going to be lost essentially. No one's going to bother to try and get them out of the devices again, and overall we have a resource depletion. So you could say, e.g. gold, silver, whatever. Another thing I think of when we're talking about environmental impacts of computers, things like contamination. So I've done it apart here, but they're kind of linked. So there are other resources like lithium is the one I could think of. I was trying to think of any other toxic things used. So lithium batteries, for example. Again, these seem like they're desktop computers. It's not really relevant, but it's just in the general sense. But they could contaminate water. So you might want to talk about contamination if you got a question like this. Also, air pollution, you'll be a little bit careful. So obviously there's a lot of energy being used for electricity, and it depends where the electricity is or how it's being generated. If it's non-renewable, then the marginal effect is zero on the environment, but the actual maybe the manufacturing process is going to use a lot of energy, and so that's bad if it comes from things like fossil fuels or burning coal, which is an example of a fossil fuel. So a couple of ideas here. So I might as well show you the mark scheme. I'm pleased to say a couple of ideas came up. So it lists these 3 types of pollution. I'm not sure if there's any more. These are only 3 I could think of. So they say from a manufacturing process, yep, that's something you could write about. You've got to make sure you link it to not only computer use, but also how it actually affects the environment. So just saying pollution on its own probably wouldn't be enough. You'd have to relate it to where the pollution is coming from and the effects of it, maybe. So you could say pollution that contaminates a water supply, or noise pollution maybe from a factory that creates a device or something. Again, it talks about contaminating groundwater, this time from mining minerals. The countries that these devices are built in, usually China or just Asia, maybe minerals come from Africa maybe, or maybe in South America. But the countries are chosen because not only they have these reserves, but they have a lack of regulation. Whereas in England, a factory couldn't just churn out loads of air pollution, it couldn't just churn out loads of CO2 without the government cracking down on it. In countries like China and the other countries these are built in, there's not this regulation because they want this economic growth, they want their prices to be low, in the same way that they might allow child workers in some countries. That's not allowed in the UK, but it drives prices down in the countries, and so say Apple can exploit these low costs at the expense of environmental impacts in those countries. It talks about toxic components, which things like lithium, it says lithium here, and it might be good to be aware that you have to specialise. You have to go to specialised disposal facilities. I'm sure you know that you can't just throw batteries away. And devices into landfills, again, contaminate ground and water resources, obviously like that argument. And the impact I didn't talk about, but this list is slightly, I don't know if I'd write anything on this list actually, but I'm sure an examiner would be pretty lenient with this because there are so many things you could talk about. So a lot of it talks about legislation. I suppose the legal issues is part of this topic too, so maybe they're trying to link it somehow. I'd probably talk about recycling the devices, maybe power saving mode or something like that, but these are the suggested ones on the mark scheme. Part B says the company uses a database to structure its business data. Give 2 reasons for choosing to structure the business data. So it does say database here, but really it's talking about structure it in a database. That's just something you've got to pick up on, but it does say database here, to be fair. So the most obvious one for me would be you have the ability to query, essentially search for things. That's what SQL stands for, structured query language. So the structure is in the first bit and then you have queries, so they're very much related. So you can query a lot easier. I don't know how you'd really query it without a database. So you could say search, presumably. That's almost synonymous, although query is a more technical term, I suppose. Second point is not as obvious, I suppose, but the ability to better organise data is really what the structure is there for, to, I should say, organise data. Also ones I could think of but aren't as obvious are things like you can sort for data a lot easier. As in tables, you can sort it. Also database management software or systems have the ability often to produce reports, so that's very helpful for a company. They can just produce a report based on the data, but this would be enough for 2 marks. For C, we have a relational database constructed by the head office to hold this business data, and there are 3 tables for this relational database, with the employee, works at, and outlet. And for I, the field at A, so the field is the column, emp id as a specific function in this table, so this table here, state the name of this function. So this field here, let's highlight it. This is going to be our primary key, and this is, I guess, slightly exam technique. Pretty much anything to do with an ID is going to, an ID is always pretty much unique. It might just be unique for the company, obviously, but ID tends to mean unique. And a primary key is something that uniquely identifies a field in a table, or actually uniquely identifies a table. So the only one here really that's definitely going to be unique. People have the same last name, the same first name. Obviously, you could have people living at the same address but work at this place. They could be born on the same day. National insurance number is unique, but ID is almost always the primary key. So the next part is very similar to the first. We have another field, this time in a different table. So it's outlet ID in works at here. State the name of this function. So only something I noticed now, which is maybe not good, but you can see we've got a little key here, and this is obviously, you can work out designating this as the primary key. I should have noticed it before, but there you are. So we have, let me go back to my highlighter, we have outlet ID in the outlet table. So we have, so first of all, it's not for primary key because we're looking only at works at. It's not for primary key because it's WAID in this example, but we're linked to this other table, and this is what kind of defines this key, and this is a foreign key. So this is when you have the primary key of one table also in another table, and then it acts as a foreign key. So that's how you know it's a foreign key rather than a primary key, because this little key thing here, and you can probably get it anyway because it's linked to this. So the third part is really just asking about what I was just saying. I don't know how well I expressed it, but it's sort of hidden under the guise of, so the same field has the specific function in the database. So we're talking about the database rather than this actual individual table. And so really it's asking what a function of a foreign key is. So really it's there to, or what a relational database does, that's where the relation comes from. We form relationships between entities. And I talked about this in a video about different types of relationships. So really it's there to form a relationship between, essentially where I've drawn the arrow between these two tables. So let me think how I'm going to write this. So I've just said to form a relationship between the two tables, pretty much identical to one of the options on the mark scheme. So the top one here is pretty much what I've written. Same sort of ideas, same general idea. So that would be the answer for this. AJ's Grill has relocated to 360 Pinnacle Place. The data has obviously changed to reflect this address change. And we're showing the original record for AJ's Grill. It's here. Record is the same as a row. I'm not sure if I said that earlier. And it's shown in the table outlet. And we have to construct a SQL query to update the location of AJ's Grill to 360 Pinnacle Place. And so 3 marks. And I can straight away see how this is going to break down without having looked at the mark scheme. Because okay, let me start from scratch. So the first thing you need to appreciate with this question is we're updating the database. We're not inserting a new record, we're not deleting a record. These are the other SQL type queries you could be asked about. I cover all of them in my video, so if you're confused about this, make sure you learn this. You know, this isn't a 1 mark question. You could get more than 3 marks for this, so make sure you actually revise this. In fact, let me grab the syntax from my presentation. So this is just from, I think I got it originally from Edexcel's actual specification. So right at the bottom of the specification, it's a list of SQL statements they want you to learn, and obviously I covered in my video, but really I didn't do much more than show you this stuff, because this is the format they want. So you're gonna get a mark for each of these lines. So this will be mark 1, mark 2, mark 3. So it's pretty straightforward, really, if you've learnt it. So you might want to print it out. You might want to stick it on your wall. Make sure you learn these SQL statements because it could get you 3 marks in the exam. So first of all, we need to we need to specify the table we're updating, and this is table outlet. So we tend to do it in capitals, keywords, not just in SQL but pseudocode too. So update table outlet. That looks awful, but there you are. We then have to actually set. So the column or field is, which one is it? We are what are we doing? We're updating the location, so it's this one we're changing. And so set outlet. Just try and copy it out as it's written. I don't think you'd ever lose marks for it, but you never know. So 360. Notice how I'm going to do it in quotes. I don't think it matters a ridiculous amount, but it's a string, so you've got to be a little bit careful. 300. Pinnacle place. And then we need to actually specify. Right now, all we've said is the table, so the general table, and also we're setting the address. So we're specifying the actual address we're going to be setting, but this could appear in more than one record, so we need to actually specify the record, and this is where the primary key is going to come in. The ID is unique, as we can see if we go all the way back. This is the primary key for the outlet, and as I say, ID tends to be anyway. And so the thing that uniquely identifies this record that AJ's grill is in is the fact that this outlet ID is 2. We then usually do a semicolon at the end just to wrap it up. The handwriting's got very dodgy, apologies about that, but I might as well show you the mark scheme again because it's interesting. It says to do not penalise against syntax such as brackets, semicolons, quotes for not important syntax essentially. So, bear that in mind. But having seen the exam report too, so this is where the exam report is really useful. They say this question was not very well answered, and that suggests to me if there's some dispute over how long ago papers were written. I was told once that it's 1.5 years, although I'm not sure about that. So if they were writing the June 2016 paper after they wrote this examiner report, then I would be, if I was a person writing this paper, I would make it intensive on SQL, see if students have picked up on the fact that actually some people didn't even know any of the syntax, and they say the centres are reminded that it's on the specification. So if I was to predict what questions could come up in the next 2 years, I would say there's going to be a lot of SQL stuff because it's clear that most people didn't prepare for it, so bear that in mind. Alright, for part E, we're told the characters in this field, last name, are stored in Unicode rather than ASCII. So 2 different representations for characters, 2 different character sets. You might also hear it referred to as that. So ASCII, the original ASCII used 7 characters, but it now uses 8 characters for extended ASCII. Unicode uses 8 bits per character. Unicode uses 16 bits per character. So going back to what I was talking about before, about combinations, so 2 to the power 8 is 256, 2 to the power 16 is not something off the top of my head, so I should really do the approximately equal. It's about 65,000. Obviously it's going to be multiple 65,000 roughly, but anyway, clearly it's much larger than what ASCII can represent. So Unicode, ASCII, the A in ASCII stands for American Standard Code of Information Interchange, so it's only based on the English language, it's only based on American characters like the dollar. So Unicode gives us many more options, but we've got to relate it to the context and answer. By the way, we're told we give a reason why this is appropriate choice. So appropriate really is referring to the context. Edexcel seem very heavy on relating it back to the context, and probably rightly so. It's only 1 mark. So the most obvious answer, the one I'd probably put, is about foreign characters, so like an umlaut. People have those in their name. And other characters too I don't know of. So I've just said Unicode can represent more characters than ASCII. I probably should have written. So for example, foreign language characters, people's last names. You've really got to relate it back to whatever context is given. When you're going to your exam, make sure you bear that in mind. Keep relating it to the context. If there's any mention of the context, keep relating to it, because there seems to be a load of questions about this, and you're only going to get a mark if you relate it to the context. So it turns out that what I've been talking about a lot so far is in this question. You can tell I haven't really looked ahead. So we're told that another field, national number, is a positive number, 8 bits in length, identify the range of values that can be represented. So it's exactly what I'm talking about before. So we're using binary, 8 bits because for binary, so it's only 1 mark, there's no mark for working, but 2, because it's base 2, to the power 8 is 256, as I literally just said. But you can't just write 256 down because it's a range of values, and this is really important actually. One thing I remember getting, I don't know why it confused me, but for some reason I didn't get that you had to count from 0. So for hexadecimal, you're going from 0 to 15. It's base 16, but you're not going up to 16. We don't have a 16th. We don't have a representation for 16 in hexadecimal. So that's my own misconception when I first started learning about conversions. So the range is going to be 0 to 255. So this is 256 in total, but in terms of range of values, 0 can be represented with just 8 zeros when we're using 8 bits. So it's 0 to 255. For G, we have another network type question. We're told that the head office of AJ's has decided to use server-side scripting to allow the individual outlets to access the new database. That's one of the features which you wouldn't write about because it kind of talks about it here. You can interact with permanent storage when you use server-side scripting. So we have to give essentially 3 other features of server-side scripting. So let me get rid of that because it's a bit annoying. So server-side is obviously processing on the server, so this could be a very easy point. So all processing, a script is just something that's can execute by itself, sort of without any interaction. So all processing is done by the server. I've just looked at the examiner report, and they say one of the main misconceptions of this question was people confusing it with the client-server model, which is different completely. So they use both client and servers, but they're not the same thing. So make sure you have that clear in your head. Another feature, especially in this context, is there's no no database management software would be installed on the client's computer, the individual outlets, because it's all done by the server. So there's no plugins, there are no software in general stored on the client for this purpose. And another feature that's commonly written in textbooks is it means you don't have to update the software. You don't have to update it on the client's computer. You only have to update it on the server, not the individual. It could be many outlets that you have to update if you're going to update your software, but you only have to do it on this one server. Another feature that's commonly talked about is that server-side scripting tends to be a lot faster than client-side scripting because it's all done on the server. Server's usually very fast. Also, it tends to be more secure than client-side scripting because the server is usually well protected, less vulnerable ideally. So this could probably be 2 points, but let's just say more fast, and let's just say secure as well, because it doesn't have to be perfect, more secure than client-side scripting. You could obviously get the same type of question but with client-side in your actual exam. So some features of client-side scripting would be the fact that you do need things like plugins, but it doesn't mean it can be much more. Web pages can be much more dynamic if it's just done on the client side. Also, instead of interacting with this permanent storage like a database, it can interact with things like cookies, which are also in the course. Cookies are just a small store of data used to send back to the server information that has been collected about the client. Also, I guess you could, if you actually got this question, you could basically say the opposite. It'd be less fast, less secure than if it was on the server side. Part A of question 5 is the first longer mark quality of communication question in this paper. You're bound to get one in your exam too, and they're actually not that bad. I think people maybe, I suppose if you haven't revised the topics that the question is on, you're going to be in trouble. But often, not in this case, but often lots of questions that are worth 6-7 marks maybe are application questions. You don't have to write 6 or 7 points to get 4 marks. You have to write a couple of points each side. I mean, you get marks for your written communication, so no bullet points, no dodgy spelling. Make sure the technical language is perfect, and you're going to get the higher marks. So in this case, we have to discuss the suitability of compiled and interpreted programming languages for the student being a beginner who's decided to learn how to program. So straight away, that suggests that they are a beginner, which is important for answering this question, because we have to come to a judgment, and a justified judgment of that. We always have to justify it. and it's good to do a judgment anyway. It's not always explicit saying you have to make a judgment, but in general, in all your subjects, it's good to come to a judgment, and it's better not to say something like, in conclusion, just make the judgment and back it up. So I always do a quick plan for longer mark questions, so I'm going to exaggerate that a little bit. I probably just jot down tiny notes to help me, because it helps you do your structure, because you are getting marks for your written communication. So a compiler, so by the way, it's talking about, I can see it might be a little bit confusing, because when you see programming languages, you might think it's talking about high and low level languages. It's not. It's talking about two types of translator, the two you need to know. So a compiler works by translating the whole source code in one go, whereas an interpreter works line by line. So it translates line by line. So it translates a line and then executes it, whereas a compiler translates the whole code and then produces an executable file which you can then execute after that. So the interpreter is doing it line by line, which affects the end result for the student. So we also have to relate it to the context, as I've said many times so far. So the fact that it does this line by line is good, because a beginner is likely to make many mistakes, as I'm sure everyone who's programmed will appreciate. You make lots of mistakes when you're a beginner. So the fact that it does this line by line, a compiler will only know you have an error after the whole code has been translated. If it's a very short amount of code, it's not a big deal, but if it's a long bit of code, it could take a while to compile, and so you only know you've made an error, which could be in like the first line, at the end of all of this. Whereas an interpreter will pick it up straight away, and it will tell you which line it's happened on, because it stops at that point. So this can be very good for debugging, which is the process of finding errors, so it's because it runs line by line, but also just making errors in general is a lot, I suppose, a lot less frustrating when you're using an interpreted language. Although, having said this, at GCSE you very much get the impression that there are two types of language. You have a compiled language and an interpreted language. In reality, it's not quite so black and white. Modern languages have very clever translators, and they'll use bits of both. So it will translate from high level a bit of a way. It will translate to kind of intermediate code, and then it will translate to machine code, which is zeros and ones. But actually, even this process can be split up. So you might say Python is an interpreted language, but in reality it will use elements of a compiler. So it's quite clever in that way, but we're obviously not going to that level right now, and it involves another translator you don't need to know about for your course, so we'll leave it there. A couple of other points I don't know if I'll include when I write this up. I'll probably type it up to save me having to write it all out. So a compiler, the actual executable file produced, so the result which you can then execute, is going to run faster than if you had to start the whole interpretation process, because the interpreter is translating it then executing it, whereas just having the executable file on its own, you just have to run it. You don't have to translate it again after you've compiled it this one time. But this doesn't account for errors, so that's something you can write about. Also, an advantage to a compiler, and why things like proprietary software uses a compiler, is you don't have to have the source code. So no source code needed after you translate it, because essentially the executable file is standalone. You don't need the compiler or the source code to execute the executable file. You just need the file itself. Whereas an interpreter, you need the source code and the actual interpreter program to be able to execute the code. So you have essentially less things with a compiler. So I'll just type this up and to save a bit of time, and I'll show you in a second. So I maybe spent about, 4 minutes, say, typing this up. I know typing it up is quicker than writing out by hand, but you don't want to spend too long. We'll talk about this at the end, but if you're doing a minute a mark, then you don't want to spend 15-20 minutes writing a whole essay on something you don't need to write that much about. If I just talk you through it. So I've said that the compiler scans through the entire source code, translate it all in one go essentially, whereas an interpreter translates it line by line, then executes it, which is quite an important point. It's easy to forget the execution bit of it. And as I said, which is very relevant to a beginner, for students, should there be an error, a compiler will only generate the error report after the whole code has been translated, whereas an interpreter will immediately show the error and stop executing too. And as I've said, because it's a beginner, I'm making the point that they're likely to make more mistakes, which I think is a fair enough point to make. the interpreter will stop execution immediately after an error and show its location. But actually fixing the code means you don't have to just keep recompiling it a lot of times. You can just keep interpreting from the point before the error, which is very useful, especially in debugging. We actually have to fix and correct the errors. Despite this, as I said, the executable will run faster than the interpreter having to translate and execute line by line, because it's having to do this extra stage, and the compiler is often more optimized too. So I've said in conclusion, our justified conclusion is that in general, a compiler is usually more practical, but due to the inexperience of a student in this situation, an interpreted language will probably make it a lot easier for them. So hopefully that'll get me the 6 marks. We can look at the mark scheme now. To get the top marks, you need to make relevant points in both categories, which you'd expect. You need this well-justified recommendation, which is a good takeaway for you because you might not realise that. So go in, always do a justified conclusion, and as we say, it needs to be used, your spelling, grammar and punctuation needs to be used accurately. So in terms of the specific points I've written for this question, I talked about a couple of these. You really don't need to talk about that many. Worth noting that you can't make bullet points, as I said earlier. It's only worth 2 marks max. You could write all of these points and only get 2 marks if you use bullet points. So bear that in mind. If that's a technique you have of writing answers in bullet form, don't do it for these type of questions. So in terms of the general points, not the general, the specific points, the ones talked about, it translates all the source code if we're using a compiled language. Points you don't really need to know about at GCSE level, so don't worry too much about it. Even knowing about object code is good, but maybe not essential. But things like you don't need the compiler or the source code to run the executable file, that's quite important. In terms of portability of the using a compiler, I talked about this a bit in the video, I believe, but again, it's slightly above GCSE level, I suppose, although a lot of stuff in this course is, to be honest. Things like the file running quicker than an interpreter with the source code is one thing I wrote about, and having to recompile each time is another point I wrote about. We also have to talk about the interpreter to get for 6 marks, as we just saw, and things like the debugging could be easier because the interpreter immediately identifies the line of error, and just for definition of interpreter, it's translated 1 line at a time, then immediately executed, and runs as quickly. So it's just kind of your converse points here. So that's about it for this question. I think the main takeaway would be make sure you do the well-justified recommendation. That's really important. Part B says the student has now written an algorithm. The image shows the pseudocode of the algorithm, and we have to state the line number that shows the initialization of a data structure. Data structure is just the abstract definition would be the conceptual arrangement of data, but in implementation it's really things like arrays, lists, dictionaries, tuples and so on. So we have an array here which gives a gateway. This is our initialization, so it's the first assignment of a value to the data structure. In this case, the first initialization of a variable would be f here, but that's definitely not the question, so it's going to be line 3 is going to be our answer. We then have to state the range of line numbers that show a repetition. So this is one of the 3 constructs you need to know about, and the repetition is a loop, and you can see we've got a while loop here, so you should recognise some programming. So it's this bit, so lines 9 to 16. One mistake maybe would just be including the body of the loop, but you have to also include the loop conditions and the end bit as well. For C, we have to complete this trace table to find an error in the algorithm, and as you can see, I've just copied the code to stop me having to scroll up every time. For part C, we have to complete this trace table to find an error in the algorithm, so it's only worth 2 marks, and as you can see, I've copied the code to stop me having to scroll up and down the whole time. So a trace table shows each variable, in this case, at each stage, so when it updates you just write it in, but hopefully you'll see me do that. Hopefully you'll pick up on what I'm doing as I go through it. So we have our initialized values here. An array with this I is our parameter, and it's going to index the array. So we're doing 0 indexing. When it doesn't say you're not, assume we're doing 0 indexing. So this is in position 0, this is position 1, 2, 3, 4, and so I is going to be, as you can see here, we're going to use the value of I here, which is going to be updated. So let's go through it. So we have all of this is all done for us. So the first line is all good. We're then going into our loop. So while at the moment f is false, so not false is true. So let's just write it in for now. So while true, well, it's true, so we're going to loop until f is true, because not true will be false, and then we won't loop. We'll just return C at the end. So if an array I, so at the moment I is 0, so an array I, let's write that in, that's our first bit that's getting evaluated by the language when it's actually going to be executed. This is pseudocode, so it's not ever going to be executed, but we can hand trace it using a trace table. So an array 0 is going to be the index, so we're using index of 0, so it's going to be 78, equals b, then set f to true. Well, b is 75, so clearly it doesn't equal 75. So else we have to set I to I plus 1. So this is the next stage. We'll move on to the next line. So I plus 1, 0 plus 1 is 1. We then now at the end while bits we go back to the start because it's still true because f is still false. So we do it again. So if array I equals b, so an array I we now have I is 1, so it's this position. So now we have 83 here. You can see that they're each different stages while we're doing two different lines. It's fine to leave gaps. That's how trace tables always end up looking. Not everything is updated at the same time. So it's still not equal to b. 83 is not equal to 75. That's what will be evaluated in this little bit here. So we're going to the else statement, set I to I plus 1. So I is currently 1 plus 1 is 2. Same process again all the way back. An array I this time is 72 in the third position, but with an index of 2. And then it's still not equal to b, so we do this again. I plus 1 again is now 3, and then it's now 80. And then it's now going to be I is now 4, and now it's going to be 83. So an array is now 83, and then we again go to the else statement because none of this applies. It's not equal to b, and so we have to do I to I plus 1 again. So this is now 5. And actually this is it because we have encountered the error it's asked us to find. We don't have to do anything to say we've got to that point, but hopefully you can understand what the error is, because essentially we've run out of space in our loop and it's still looping. It's still so as it goes back, it's going to use I equals 5, but an array 5 is nothing in position 5, and so it's going to have an error. That is the error, and it won't end up ever putting anything for the value of an array 5 because nothing's there, so it's going to basically force to stop at that point. So you might be able to work out anywhere, but it tells us that the error of a bug is in line 9, so let's change colour. This line here, I can tell that without even knowing, just double check, so that is 9 as I suspected, because I can work out what's gone wrong here, because we keep looping anyway, despite the fact that we've gone outside our range of I, the index. So we need to basically change this to say we're going to stop this loop after we exceed the length of the array. So we need to basically add another condition to this, so we need to do an AND, because we need both conditions to be true for the loop to execute. So we need AND, it needs to be, so I needs to never be 5, because if I ever becomes 5 or more, this whole process is going to produce an error, because this line here in the body of the loop is a problem one, because we can't go beyond the length we already have. So do some brackets. In fact, let's just do it in its entirety. So while not f, so this bit's fine, that's perfectly valid. Then we need to do and I is less than 5. You could do I less than or equal to 4, that would still have the same effect. Hopefully you can see what I've done here. So we need this else condition we have to do at the end. So we need both sides of this to be true for the loop for it to execute the loop, and you can only do that with an AND operator. So as the mark scheme illustrates, there are many ways you can do this, but this is my one here, and they're all the same concept. So we have to then state the purpose of this algorithm. I get the sense that these questions are definitely discriminating for the people who are going to get the top grades. They have to put in certain questions that challenge for people who are going to get the top grades, and these are, I suppose, in regards to the rest of the questions, relatively challenging. So state the purpose of the algorithm. Hopefully you would have, well, if you followed this carefully, you understand that actually what we're doing, we're trying to find, and I guess this gives it away here, the return line in this function. We're returning C. So C is going to be, if you look at this bit, first of all, if the position, so say I is 2, if the position in 2, which is this one here because we're 0 indexing, equals our target, so B is essentially our target value. We're trying to find whether B is in this array, and if so, we're going to return its location, because it's going to return the index, and this is the location of the target, which is B, so in this case 75 in this array. So if this was 72, it would set C to I, so I would be 3, so C would be 3, and then we return C, which is 3. So it would give the index position of the target, which is B, in this array. Hopefully you can follow that. So as I say, just returns position, or the index of the target number, which is B, the variable B in this case, in the array. It's not just finding B, it's returning the location. It's really given away by this bit here. The final question in this paper is one people will probably either dread or look forward to, depending on how confident they are with programming. And so you have to basically write an algorithm for this problem. And this is, you're going to have a user provide a series of numbers representing the weight in grams of fruits. The weights are always positive whole numbers. That's important, because we're going to be careful of our data types. The number of weights to be entered will also be provided by the user, and the solution calculate and report the mean weight of the fruits to 2 decimal places. So I've just done this on paper, so I'll essentially be copying what I've just done. Very, very similar, if not identical, to the mark scheme, but this isn't the hardest problem I've ever seen in my life. They can be quite tricky, these last questions in exam papers. I don't know about the sample papers, but this isn't the hardest one I've ever seen. The hard bit, I suppose, is this bit, and this is again discriminating against the higher tier candidates, I suppose, which we have to do. So it shows 2 examples of the executing solution, so we've got to sort of mimic what we're doing here, the message to the user essentially. And we have to write an algorithm for a solution using a programming language you are familiar with. I've never seen this before. This is the only exam board that asks you to actually use a programming language. I don't know what your teachers have said about this, but I'm going to do it in pseudocode, because that's what the mark scheme has their solution in. That's what Edexcel are going to show you bits of code in. It says on the mark scheme you're not going to be penalised for syntax errors, which suggests that it doesn't really matter how you do it, as long as it's pseudocode. As long as you don't use a flowchart. The exam report says some people did use a flowchart. I don't know why you'd even try to. And it's worth 7 marks, by the way. Even if you weren't very confident about this question, you could still get at least half of these marks of stuff that's not that difficult. So always do something, even if you don't think you can do the answer. So we have to work out the mean. If you don't know, the mean is just all the weights added up. This sigma just means add up all the weights and then divide by the number of weights. So that's what we're going to be doing. That's going to be our kind of final calculation we have to do to find the mean. So if we start, first of all, by initializing a variable, so we have to, first of all, we need to initialize a variable. So we need a total variable. This is what this is going to be represented by, the total number of weights, and we need to initialize that to 0. You always pretty much need to do this. Your programming language might not be too fussed about it, but you have to, at least in plan, always initialize your variables. So again, using the convention I have up on my second screen, it's on the appendix of a specification. We have to set total to 0. This is how Edexcel do their variables, if you haven't noticed by now. So we have to initialize it to 0. It's 0 at the start. We're going to be looping through it and adding stuff to it in a second. We then need to get this bit. So we need to ask the user how many weights do you want to enter, and then we need to store this as a variable. Let's call it number. So this is the syntax Edexcel uses for the input stage. So this is just asking the user, sending it to the display, how they write it, how many weights you want to enter. I've copied exactly what it says here, because that's probably what they want you to do, but I don't suppose it matters so much. The second part of this is to actually receive the value. So you kind of set it as a variable. I think there are 5 languages that you can do for this course, and I don't know all of them. I remember seeing the list at the start, so that's why I'm not doing it like that. I'm doing it in pseudocode. But I would personally probably use the same kind of conventions as your language. So if your language uses, so instead of this line, total equals 0 like most languages do, maybe you have a semicolon on the end, and maybe you have to declare the data type or whatever. Do it similar to your language, but you can do pseudocode for bits you've forgotten how to do. I often have to look up things like you have to calculate it to 2 decimal places. I'd have to look up how to truncate in my language. I don't remember it off by heart. So you can do pseudocode for bits like that. If you can't remember to do something in your language, just do pseudocode. You're not going to get penalised for syntax. So continues receive number from, it then does the data type, and then from the keyboard. A bit of a long process, but that's how Edexcel do it. So we've got our number of weights, this bit of the calculation. We then need to enter all the weights. So we're going to repeat however many times this is. So in this case, there's 3 repeat. It repeats this 3 times, and 4 here 4 times. So we're going to do a loop. So you could do a for loop, but I'm going to make things easier for myself and do just a nice pseudocode loop, which I'm going to call, well, it's actually on the Edexcel on the Edexcel pseudocode. It's just a repeat. So you just say repeat number times, and I'm going to indent here. Like some languages like Python use indentation as part of their syntax, others you can just do it as a technique to make it more readable, makes it easier for the exam, and even straight away it's getting a bit congested. So repeat number times. We're then going to have to get another input with each weight. So again, we're going to do this whole process again. So I'm going to call this variable weight to keep it nice and simple, and then we've got to do from as well, and then for the data type it says here, and this is where this comes in handy, it says the weights are always positive, whole positive numbers, so these are integers. So the data type is integer here as opposed to another numerical data type like double in your language if you're doing something like C#, or float or real. So receive weight from integer keyboard. So we then need to add this weight to our total, and this is where we need to initialize it. And when I did this on paper, I forgot this line, and when I got to this point I thought I'd better go back and initialize it. You always seem to get marks for initialization. Every exam board I've looked at, they all have very similar questions. You always get a mark for initializing your variables, your array, whatever you're using, because it's good programming practice, even if your language doesn't actually require it. So if we have to do this clunky pseudocode, it's going to be set total to previous total plus 1, and you see this a lot. We saw it in the just previous question of a trace table, where you use the previous value of it and then add something to it. So get used to seeing this, very useful. And we can then end this loop. So we're going to go back to our left hand side, we're going to ignore the indent, so end repeat. If this was a for loop, you'd write end for. It's always good to do end condition. If your language doesn't require it and you're doing it totally in the programming language, then that's fine, don't do that bit, but for the pseudocode I am. So we then need to actually do a calculation. I did this in a slightly clunkier way to how Edexcel did theirs, so I'm going to use Edexcel's way because it's better. So we need to set, let's call this variable mean to, I mean, this is where me and Edexcel differed, but this is a better way to do it. So I set the data type to real. I did do this but on a separate line. So set mean to real, and then we're doing our calculation. So it's our total divided by number. That's how we calculate the mean. And the real is needed because if this is done implicitly, these are both integers, so our answer is going to be an integer if it's done implicitly. So we tell it it's going to be real because we're doing it to decimal places. A real is a fractional number, so we have this decimal bit as well, not just the whole number. So we need that for our output. We then need to output our average weight for mean. So again, this is a bit where I've looked at mark scheme and basically used what they've done. So this was all what I did. Send. So average weight is, they've dealt with this by just using this thing to limit the length. So this is basically make it 2 decimal places. I did it a very slightly different way. I don't know if I'd get a mark for it, probably, just by basically doing it more in a pseudocode way. So and I've just done plus mean, which is our calculated value, then in brackets to display. So this is just the attempt to deal with it to deal with the 2 decimal places, and you want to look up how you do this in your language. I would have to look up for a couple of them because I just would completely forget how to do it. Sort of thing you have to look up, try and find a forum or something to work out how to do it. So this would be our solution. If we can look at the mark scheme now. So it does say that many alternative solutions are possible. I don't know about that. This is quite a simple problem. I don't know how many drastically different solutions are possible. And I guess it says you can use an array, which is fine. So these are actually what the marks are broken down into. As I say, always a mark for initializing your variables, arrays, if you're doing that. Also input. So as I say, you can pick up marks for really simple things, nothing too complicated. Any loop with the correct bounds. So they did a for loop in their example. Apart from that, mine's pretty much the same. I didn't do comments. These are comments here with a double / add a beside loop, you get a mark. That's how you do that process. I can't think of another way you do that. I guess maybe across an array, but still you need a loop. Calculating the average, and then outputting the average. So these are like 4 marks for very simple things, and then you get a mark for attempting to deal with the conversion. I guess that means the decimal place as well, but I'm not totally sure. Going now to the examiner report, they say some common errors, which may be obvious ones, such as not initializing, not understanding how to calculate a mean. That's quite fundamental, and not understanding how to use repetition. That's sort of the only way I can imagine you would be able to constantly add up the weights. They talk about indentation. That seems to be an issue with Python. In Python, the white space is important, as you'll know if you've learnt it. And if you drift left, as they say, it's easy to do when you're handwriting. It's hard to do when you're typing it up, so which is why it's a problem here. It will drift you outside the loop. The scope is sort of lost when you lose the indentation. So they give some actual people's work, which is always interesting to read. You can see this person's used a different way to format it, and this looks like Python to me, which you can look at if you want to. This is publicly available, and just some summary points which the exam board have helpfully provided. Some obvious ones which apply to any exam, attempt every question. This is an hour and a half exam. Sorry, no, it's not. It's worth 90 marks, and you get 2 hours to do it. So you have half an hour free if you do it at a minute mark. But as we saw at the start of the paper, there's lots of 1 mark questions which I think would take most people longer than a minute. It might take me longer than a minute, especially the ones where you're converting. Maybe if you've got a tricky 2's complement question, it's only worth a mark. So a lot of the questions I think you'll spend more than a minute a mark, which is where that buffer of half an hour is for, and you might want to give yourself, say, 12-13 minutes to do the last question if it's something you've picked up as being something you think you're going to struggle on, if you've done these 3 papers available to you, or 4 if you're doing it a year later. There are a lot of questions though, so make sure if there's a question you're stuck on, skip it and come back to it. That's my technique. As soon as I see a question I don't know the answer to immediately, I skip it and come back to it, because often it will come to you as you're doing the other questions sort of subconsciously. So that's something to bear in mind. In terms of other things they say here, they talk about context. I've said this many times, seems to be a very common theme with Edexcel. So take in the context of information. Sometimes there's a lot of information even for a 1 mark question, but you've got to use it and then respond using this context. Try not to give general responses. The examiners say use subject specific terminology. This is a technical subject, you've got to use specific terminology. Again, the keywords in command words in the question are there to help you, they're there to tell you what to do. We saw in the 6 marker that it didn't say to come to a justified conclusion, but it needed you to, so that's something to pick up on when you actually do this exam. Also, it's good practice to use examples. Often it's easier to use an example to express your point, such as with the run length encoding algorithm question. I need to draw a little picture to explain it. Also, this is hard when you get like a 4 points, a 4 like advantages for something, 4 features, or was it 3 features of server-side scripting. It's hard sometimes not to repeat responses, but there's no point, because you're not going to get marks for saying pretty much the same thing. The examiner's not stupid. And also they say there was some confusion between similar terms like the client-server model and server-side scripting. They're 2 different. They do overlap a little bit, but they are 2 different concepts, and things about the high and low level languages and the 2 types of translator. So that's the end of this video. Hopefully it was useful. I hope you do really well on your exams this summer. This is a difficult course. This may well be your hardest GCSE. There's a lot of stuff here which could feasibly come up at A-level. Things like floating point, fixed point, the algorithms. You need to know about sorting and searching algorithms. All of them are covered in the videos on my channel that cover this course. I like to, when I do my GCSEs, watch videos if they were available the night before the exam. That's one of the reasons why I made these courses, because I like to do that, and there wasn't videos on these courses before I made them. So you want to do that. Revising before the night before, at GCSE level at least, can be really, really helpful. I only revised for some of my GCSEs the night before the exam. I didn't do revision weeks ahead, which was a mistake, but I managed to pull it off somehow. Friends of mine sort of just stopped revising as soon as it became May 12th or whatever time it started. Stopped revising for some reason, I don't know why, and you could tell with the grades. So keep working, keep revising, and hopefully you do really well. Thank you for watching.